All right, we're gonna look at our lessons for this week. If we go to Buzz, we see we have lesson 5.01, 5.02. So I want to cover some of that in class today, just to give you a kind of a rundown of what those two lessons are. And let me pull up Buzz here on the screen just to have that reference so you know where you're going. I've looked at these two lessons. I've not done the assignments yet myself. I'm behind. I got till Sunday at midnight, right? They're not due yet. So you can see the check marks. I've already gone through these two lessons. I still have to do my assignment. I'll get that done before Sunday. But arithmetic sequences and arithmetic series. That's what we're doing. Next week, we'll move into geometric. Gets a little trickier. But still, the arithmetic sequences. And let's talk about what an arithmetic sequence is. It's a sequence of numbers. And it's arithmetic because it's just adding or subtracting. That's the only arithmetic we're using in that. So it starts out on the first page with this sequence of numbers right here, and it wants you to find the next three in the sequence. So it's 8, 23, 38, 53. So if you look at it, what's going on here? It's just adding 15 every time. Adding 15 every time. So if we add 15, go to 68, go to 83, go to 98. Submit. Hey, 63, 68, 83, 98. We were correct. Excellent. Go next. It gives you another one. This one is going -5, -7, -9, -11. Obviously, it's going down 2. It's subtracting 2 every time. So we just subtract 2 every time. We can be right there, correct in that sequence. Now it got 3, 1.75, 0.5, -0.75. What's going on there? That one is subtracting. Obviously, it's getting smaller. Since it's getting smaller every time, if we subtract each one of those, we'll see it's getting smaller by 1.25. So next would be -2, and -3.25, and -4.5. Submit. Yes, we got that right. So, oh, and it says dollars, 2.5, 3.25, 4. So just shows you what we're going to learn this lesson is how can an expression or process be determined. So is there some kind of formula to figure out an arithmetic sequence? What functions combine to create an explicit formula? And what possible restrictions exist on that? So this wants you to drag it. Is it an arithmetic sequence or not an arithmetic sequence? We'll just look at one or two of these, and then I'm going to switch over to 1, 2, 4, 7, 11. Is that arithmetic? Is it
No.
or subtracting? No, you are correct. Because it added 1, then it added 2, then it added 3, then it adds 4. That is not an arithmetic sequence. So we drag it up there. That's correct. 3, -147, -297, -447. Big numbers, but is that arithmetic or is it not arithmetic? Is it adding or subtracting the same number every time?
Yeah, that's arithmetic.
Yes, it is. It's subtracting 150 every time. Starts at 3. When you subtract 150, you get there. Subtract 150. So we'll drag that there. So then we got 10, 8, 12, 10. 4. See, that's going up and down. Goes down, goes up, goes down, goes up. Subtracts 2, adds 4. Subtracts 2, adds 4. Now it's adding and subtracting the same numbers, but not between every term. So that is not arithmetic. All right, so let me switch over here. Switch over to my pencil and paper here. And let's talk about arithmetic sequence formulas. Because there's a formula we can use to find any term in an arithmetic sequence. Let's say if we have 1, 5, 9, 13, etc. Right? 1, 5, 9, 13, etc. We can see what's going on. There is a formula we can use, and it's this. Let me write this: a to the n equals a1 plus n minus 1 times d. So let's say we got the sequence right here, and we want to know what the fifth term is. What's the next one after that? Well, if we want to know what the fifth one is, n would be what we want to know. So n would be 5. A1. See, this is A1, A2, A3, A4. A1 is the first term, which in our case, A1 would equal 1, because that's the first term in our sequence. N, again, say A to the N, A to the N would equal the fifth term, because we said N was equal to 5. We want to know what number 5 is. And then D is the common difference. Which in this case, our common difference each time is plus 4. Because every time it's adding 4. So if we substitute this in, A to the 1 would be the fifth term. So A to the fifth would be the fifth term. Equals 1, because our A to the 1 is the first term. This is the 1. Plus parentheses, N is 5. So 5 minus 1 times the common difference of 4. Okay, so let's simplify that. The fifth term would be 1 plus 5 minus 1 is 4 times 4. 1 plus 4 times 4 is 16. So 17 would be the fifth term. And we're like, yeah, that was a lot of work just to find the fifth term. Sure. But if we wanted to know the 48th term, we have a problem with this formula. Because this formula, well, let's say, no, this might work. Let's see if we can use this formula. 48th term. Yeah, this is the explicit. We can use this. So if we want to know what the 48th term is, A to the 48th. So our N would be 48. I'm sorry, let me get where you can see that. A1 is still the first term, and our common difference is still 4. So if we want to know the 48th term in this, we can either do it like this, where we keep adding 4, and we add 4 another 44 times, right? By the way, there is a formula for that. A n equals A to the n minus 1 plus D. See, if we want to know what the 48th term is, all we have to do is know what the 47th term is and add the difference. Whatever the 47th term is, plus 4, right? So if we want to know the 48th term, all we have to do is go to the 47th term and add 4. So the problem with that is we don't know the 47th term. So to find the 47th term, we'd have to say the 47th term is equal to the 46th term plus 4. So this formula is a formula to find the terms, but it relies on us knowing the term before. This one is called the recursive formula. Recursive. The recursive formula says, as long as you know the one before it, you can just add the difference and know what this term will be. Not really that efficient, right? It's fine when it's small. That would have worked great knowing the fifth term, because we know the fourth term. All we have to do is take the fourth term and add 4, and we get 17. That's a lot easier than this one. This one, this formula, is called the explicit. Recursive, have to know the one before it. Explicit, we can jump straight to whichever term. We're going to use this for our 48th term without having to figure out the 47th. So let's use this. Our first term again is 1 plus n minus 1. 48 minus 1 is 47. We're going to just jump to that step. Times d. Well, our d is 4. Okay, so the 48th term of this sequence be 1 plus, and 47 times 4 is 188. 188. So that means the 48th term is 189. Anybody wants to check that, they can go up here and just keep writing till they get to the 48th term, and it'll be 189. So this is a great way when you get to larger terms, like the 5th term, not a problem. Even the 6th or 7th, we could just go ahead and do it up here in the 6th or 7th using the recursive formula, just adding 4 each time. And we can pretty quickly make it to the 6th, 7th, 8th term. But when we jump up and we want to know the 48th term, we want to know the 100th term, we want to know the 238th term of this sequence, it's nice to have this explicit formula to jump straight to it. So that's the two key things from the first lesson, knowing the recursive formula and the explicit formula. And so you may have questions about recursive or explicit. So it's important to learn which is which. Recursive relies on knowing the term before. The only way to know the 48th term is to know the 47th term. But explicit, we can explicitly jump straight to that 48th term. Straight to that. Now, what restrictions are there on this? Well, the domain is restricted. The domain is restricted to x's greater than or equal to 1. Right? Or n's, I guess we should say, not x's, but in this case, n's. Right? We can't find the negative first term. We can't find the 0 term of this. The n has to be greater than or equal to 1. The range is in this, that's the domain. The range is unrestricted. The range is what the numbers are when you punch them into the formula. N has to be 1 or greater, but we could end up with negative 300. We could end up with positive 1,000,000. We could end up negative 438,000 because it just depends on what the difference is. Maybe it's going negative every time. Maybe it's negative 4. And so we could end up with all the negative numbers. If it's positive, like positive 4, we're going to end up with all the positives. There's no restriction to the range of an arithmetic sequence. But we can't find the negative 4th term of any arithmetic sequence. So our domain is limited to 1 or greater. Right? We can find the first term and onward. So, all right. So that is the basic summary. The basic summary of lesson 5.01. Okay. So let me give you one to try, and I'm going to have you put the answer in the chat. So let me give you a sequence here. Let me think about this. We're going to start with 7, and then we're going to do 1. We're going to do negative 5, and we're going to do negative 11, ... And I want you to give me the 33rd term of this arithmetic sequence. So you got some pencil and paper there. Let me bring that down where you can see the explicit and recursive both. You can use either one you want. It's just one's going to be a lot more work than the other, but you can use recursive or explicit. But find the 33rd term. So you need to know what if you're using the explicit, which is the easiest one to use here, because otherwise you'll have to figure out all the others. You can do it by writing them all out if you want. We need to know our A1. We need to know our N. We need to know our D to use that explicit formula. So Mia's got a number in there. Marion's got a number in there. Oh, we got just a 6 difference between the two. See if somebody can break the tie with another answer. We're going to check it together. We're going to do the whole formula here. All right, we got a few people popping in with answers. If you're still working on it, that's fine. We're going to go ahead and so A1 is 7 in this case. Our first term is 7. That's what A1 is. Our N is 33 because we want to find the 33rd term. And our difference, it's going down 6 each time. Right? 1 minus 7 is -6. -5 minus 1 is -6. -11 minus 5, -6. So -6 is our difference. So this says our first term is 7 plus N minus 1. 33 minus 1 is 32. And our common difference is -6. So our 33rd term is going to be 7. And we got to take 32 times -6. So that's a -192. Right? So A to the 33rd equals 7 minus 192, -185. Fabulous. A lot of you got that. Yeah, Mia was one number off. She forgot to subtract the 1. She just took the 33 and put in there instead of the subtracted the 1. So I figured it was something like that, Mia, because you were just off by 6. So that -6 was one more time or one less time. So yeah, just follow that. Find out what your A1 is, what your N is, and what your D is, and just substitute them in, and it'll give you your answer, -185. So the next lesson, lesson 2, deals with the arithmetic sum. Okay, we're talking about
Mr.
Yes.
Did you go over on how to find D when they don't say they give you A1? Say they give you, I keep turning off and on my microphone. Say they give you A1 is 26 and A22 is -226. Can you go over how to find a D in those types of situations?
Where if they don't give you the first few numbers?
Yeah.
So if we say that the 22nd number is something and A to the 26, that you're talking about?
Yeah. No. Yeah.
So if they say the 22nd number in a series is 110, and the 26th number in a series is 130. But they don't tell you the difference. They don't tell you anything else. They just tell you what 2 terms are, right? When we jump down. So there is a difference of 4 in there, right? 22 to 26. And there's a difference of 20. So if we know 130 minus 110, and we know 26 minus 22, that's 20. That's 4. So it's going up 5 each time.
Oh, no. Easy.
So A23 would be 115. A24 would be 120. A25 would be 125. And then A26 would be 130.
Oh, okay.
That makes sense?
Yeah.
So that would tell you right there. Now, going back to A1 would take some more work because you'd have to just go backwards from A22 by 5s. But at least now you know what to go backwards by.
Okay.
So, all right. So let's say now the next lesson talks about an arithmetic series form. This was a sequence. A series would be like if we wanted to know this series right here. if we wrote out all 33 terms, 7, 1, -5, -11, -17, -12, wrote all the way to a -195, what would the total be if we added all those numbers together? Or even this one, 1, 5, 9, 13, all the way up to 17, all the way up to 189. What would all those be added together? Well, we could do that. It would take a while if we just added all those together. But lesson 2 gives us a sequence formula, a series formula that will do that. And let me write the formula, and then we'll talk about what all the pieces are. So it's n divided by 2 times, and again, there's different ways to do this. A1 plus AN. Okay, this is one of them, and they have different situations that you use them in. So there's 2 different formulas. Two A1 plus N minus 1 D. Okay, let's talk about this. Looking back at this sequence we had, where we found the 33rd of this sequence right here, our N would be 33, because we want to know all the way to the 33rd term, adding everything up. So this would be the sum. S is the sum. So the sum all the way to the 33rd term, from the first term to the 33rd term, the sum, and we need to figure out which one of these to use. A1 for our sequence was 7. 7 was our first term, right? So we know what A1 is. It's 7. Now here's the differences in these 2 formulas. This one says A1 plus AN. N's 33. Do we know, oh, I'm sorry, in this case, A33. Do we know what A33 is? In this case, yes, we do, because we've already calculated A33. A33 is -185. So it's -185. So we can use this first formula right here, because we know that. As long as we know AN, we want the 33rd term, add up all the way to 33rd. Do we know the 33rd term? So in this case, N is 33 divided by 2 times the first term, which is 7, and the 33rd term. So plus -185 means you subtract 185. All right. So if we do that math, this will tell us how much all of that adds up to. So let's pull our calculator up so we'll make a mistake, because we're dealing some nice big numbers here. So we take 7 minus 185, because we have to do parentheses first, right? Order of operations. So this will be 33 halves, which is 16 and a half, by the way, times -178. So if we take that times parentheses, we can do parentheses 33 halves, which is 16 and a half. -2,937. That's what that sequence would be if we added up the first 33 terms of that sequence. Adding them all together is -2,937. And that uses that first formula only because we know what the 33rd term is. Let's go back and look at this first one up here, 1, 5, 9, 13, etc. We calculated the 48th term. But what if we want to know what the first 100 terms are of that sequence? Right? So we know N equals 100. We know A1 equals, let's see, it equaled 1 in that sequence, right? 1. All right, it equaled 1. But what about A100? we don't know what A100 is. So we got two choices here. We could either go back and calculate A100, and then we can use that formula. But we don't need to do that because this formula just uses the difference. This one's when you don't know. Don't know. This is when you, here, right there. When you know end term, right? When you know the end term, the ending term for this one we knew it was negative 185. If you don't know, you use this formula. So this one we don't know what A100 is, but we do know the difference. The difference on this one, 1, 5, 9, 13, was 4. It went up 4 every time. So our common difference was 4. So since we know that, we can use the second one because all we need to know here is the n, the first term, that's n again, and the difference. Well, we know the first term, n and d. So let's say, so if we want to find the 100th, adding up the first 100 terms, adding them all together, it's n over 2, and n is 100. We're just substituting as we go. 2 times the first term. The first term is 1. 2 times the first term. Plus n minus 1. N is 100. N minus 1. So 99 times the difference, the d. So 100 divided by 2, 2 times the first term, n minus 1 times the difference. So 100 divided by 2, we can go ahead and simplify that to just 50. That simplifies to 2. And then 99 times 4 is 396. All right, 396. 50 times 2 plus 396 is 398. So the 100th term added up all the way to the 100th term. We'll pull our calculator back up here so we don't make any mistakes. 50 times 398. So it would add up to 19,900 to add up the first 100 terms of the 1, 5, 9, 13, ... to A100. The sum. So taking the sum of all those numbers, 1, 5, 9, 13, all the way to A100, the sum would be 19,900. Sure. Looks like a 9, not a 7. Questions on that? So you basically have 4 formulas this week. 2 of them help you figure out which number in the sequence, like the 10th term, the 15th term, the 3rd term, whatever, using one of 2 different methods, using recursive when you know the term before. I want to know the 6th. If I know the 4th, I can just add the difference onto it. If I don't know the term before, I can use this explicit formula and jump straight to it like we did with 48. So that's those 2 formulas that you need. So those should be in your notes. So when you get to assignments and tests, you've got those. And I'd probably do an example underneath your notes of how that works. Like this, the 48th term equals the 47th term plus 4. For the explicit, the 48th term goes like that. So have those in your notes with some examples. And then you have these 2 formulas. And these are the sum formulas. Right? Sum formulas. All right. They talk about that being an arithmetic series. Arithmetic series. Put series in parentheses up there. And that's adding up the sum of all the numbers that are in a sequence. If you know what the last number in the sequence is and the first number in the sequence, then it's real easy to figure out the total number if you know the first and last term. If you do not know the last term and all you know is the first term, then you can use the second formula, because I don't know the last number. I just know I'm supposed to add up the first 100 of them. And they only gave me the first 4. So if I want to know the 100th, I can use this formula and it will jump straight to the answer for me. Saves a lot of time, not having to figure out what the first 100 are and then adding them all up on a calculator. All right. Does it look simple enough? Yeah, it's just being careful that make sure that you are using the right number for the A1, using the right number for N, remembering where they go in the formula. Don't forget the N minus 1. It's the same N, That's 100 divided by 2. That's 100 minus 1. It's the same N both times. So wherever you see N, it's the same N. Remember, A sub 1 just means what is the first term in our sequence. S sub 33 means the sum of the first 33 terms. A 33 means the actual 33rd term. So A1's the first term, A 33 is the 33rd term. Just understanding what those different things mean when we see the A1 or A sub 10 or A sub 25, anything along that lines. All right. That is pretty much the first 2 lessons. So you can go through. The lesson has some videos and some more information, some more examples. There are problems in the lesson where they'll give you a problem and ask you to find the 20th term or find the sum of the first 25 terms or whatever the examples are. So you can go to the lesson and try a few, and then once you have your answer, check the answer in the lesson and know if you're getting it right before you go do the assignment. Because when you get the assignment, it's not going to tell you if you're right or wrong until it's turned in to be graded. So you want to go ahead and try that in the lesson. Look through the lesson, see if there's any, it details how we got there. I'm just doing a summary. This is the summary of the lessons. And so I'm giving you some extra examples that are not in the lesson. So that way you can see it work live. And I know there's at least one video in the lesson where they work it live too. I think in lesson 2, I saw a video in there that where they show how to calculate that sum, just like we did here on paper. So any questions for that? Nope. Think we can handle that, huh? That's pretty good. All right. Well, I will let you guys go. You can hang around if you have questions, but I've got attendance. I've got my screen here, so I've got everybody's attendance. So you're good on that today. And we will see you. Yes, it is an A day this Friday. So we'll meet briefly on Friday too, and just see if anyone's got any questions and see how things are going. So until then, we'll see you guys. Have a great week.